Let's study about the displacement reaction in today's video. We have already covered the combination reaction and the decomposition reaction. The link for the video will be shared with you all in the description box. Before I take you through the displacement reaction, let's analyze a situation which I am giving in front of you. B, which is a stronger, we have two elements, B and A. B element is much stronger as compared to A. And when the A which is already present with a compound, which is already formed a compound, it reacts with B, then B doesn't like the situation. B says that I am a stronger one, I should form the compound. Why is A forming a compound? So what will B do? B displaces A from its position, forms a compound itself and leaves A alone. The same thing happens in the displacement reaction as well. The more reactive element displaces a lesser reactive element from its compound, and these kind of reactions are referred to as a displacement reaction. I repeat it, a more reactive element is going to displace a lesser reactive element from where? From its salt, thereby resulting in the formation of a salt of more reactive element, and the weaker element is left all alone. So this is the basic principle of the displacement reaction. Now you must be wondering that how will you, between a given pair of elements, how will you come to know that which is a stronger one and which is a weaker one? How will you displace a weaker element until you doesn't know that which among the lot is a weaker one? So for that you should know this reactivity series by heart. So what is reactivity series? It's a kind of a arrangement in which the elements have been arranged in a vertical fashion. The elements which are present in the top of the lot are the most reactive ones, and the one as we move down in the vertical series, we will reach the ones which are comparatively lesser reactive. That means it's a kind of a series in which the elements have been arranged from top to bottom, and the reactivity decreases as we move from top to bottom. So K, if you have given with two kind of elements like K and zinc, let's identify its position. K is at the top, zinc is comparatively lower. So which one of the lot will be more reactive? K will be more reactive as compared to zinc. Okay. So when you have a salt of zinc, and that is reacting with potassium, that means potassium will not be able to see the situation. It will say that I am the stronger one, I should form the salt. Why the zinc is present along with the salt? So what will it do? It displaces zinc from its original position, and K will form a salt itself, isn't it? So that is what is happening in the displacement reaction. And for understanding that which among the lot will be displaced, you should understand and you should learn this reactivity series very nicely. Please also take in account that the vice versa of this is not possible. If I have a salt of K, and that is reacting with zinc. Now again compare the series. Now K is comparatively much more reactive as compared to zinc. Now will zinc have the courage to displace K2SO4 with the potassium from its salt? No. So what will happen in this case? The reaction will not take place at all. So will this reaction take place? No, the reaction won't take place because zinc is a weaker element, and a weaker element cannot displace a higher active metal or element from its salt. So this reaction is not going to take place. Now let's do some kind of more examples which are a part of your NCERT itself. Now if I have two salts, FeSO4, and on other hand I have a salt as copper sulfate. Now FeSO4 on one side, the first reaction I'm asking you that when FeSO4 will react with copper, what kind of a reaction will take place? Will the displacement happen or will it not happen? So for this, again, I will have to go back to the reactivity series and see that and compare the positions of iron let's see. See, iron is placed over here. Iron is placed over here and copper is much below it. If you can have a look, see, iron is at the top, that means it's more reactive, and copper is at the bottom, that means it is lesser reactive. So the situation comes out to be, now in this case we have understood that Fe is much reactive than the copper because its position is higher up in the reactivity series as compared to the copper. Now FeSO4, when put in the copper solution, you know that copper is a weaker one and it does not have the potential to displace Fe from its compound. So this reaction won't take place. Now in the second case, the weaker element is present along with its salt, and while on the other hand side a stronger element is all alone. So this stronger element, the more reactive element, will not be able to take up this situation and will definitely displace this copper from its salt, thereby resulting in the formation of its own salt, and the copper, the weaker element, will be left all alone. Now let's check some kind of other equations to test whether you have understood the equation or not. Just take a pause before looking at the equation, after looking at the equation. Now magnesium and copper sulfate solution. Will this magnesium strip remain safe once dipped in the copper sulfate solution? Look back into the reactivity series. You would have understood by now, after looking into the reactivity series, that magnesium is comparatively a stronger element, a reactive element as compared to copper. Now, because it is more reactive, it will not be able to digest a situation where a weaker element is along with the salt. So what will it do? It will displace the copper from its salt solution, thereby resulting in the formation of its own salt and leaving the copper all alone. Okay, so after certain point of time, the magnesium strip will not remain in its original condition and will get destroyed. That means the reaction will take place. Like on the other hand side, if we, what we do is that if I take a copper strip and dip it in a MgSO4 solution, then in that case, what will happen is the copper, being lesser reactive, will not be able to do any harm to the magnesium salt. So this reaction is not going to take place at all, and the copper strip will remain as such even till the last of the reaction. If you have understood the displacement reaction by now, you will be able to answer the activity in this case easily. Now, what I have taken in this activity are 4 test tubes. But of these 4 test tubes, I have taken 2 test tubes in one setup and the other 2 are kept in the setup B. The test tube number 1, that is test tube number 1, is filled up with a copper sulfate solution and in it a iron nail has been placed. After the observation of time t, it was observed that copper sulfate changes into the color of the copper sulfate solution. It is a very important sentence which you should keep in mind, that the color of the copper sulfate solution fades up and turns into a green color solution. You also observe that the shining nail has got a brownish coating over itself. Now over here in the setup B, we again took the same test tubes, but now the test tubes were filled with a solution of FeSO4 and a copper strip was dipped in the test tube number 1 of setup B. After again a same time period T, we observed that there was no change in the color of the solution kept in this setup. Now what is the reason behind? Can you answer this? Just take a pause and then continue. Okay, so you must have understood by after analyzing the reactivity series again that Fe is comparatively more reactive than copper. So if Fe is placed in a solution of a weaker salt, then Fe will not be able to digest the situation and will definitely displace copper from its original position, leading to the formation of its salt and leaving the copper alone. While over here in setup B, what actually happened? Copper was itself a weaker or a lesser reactive element. So copper, even if it is placed in FeSO4 solution, which is of green color, it will not be able to displace the iron from its salt, and therefore no reaction will take place. That is why the copper strip did not lose its shine over here in setup B. While over here in A, the Fe lost its shine because the displacement reaction occurred. I hope you all are comfortable with displacement reaction by now. So join me for double displacement reaction tomorrow. If you understood the topic, kindly hit the like button. This boost again will keep me going. Also do not forget to subscribe and share so that you get the latest update. Thank you. Keep smiling as always.